And I'm very privileged to have an opportunity to present here at HDBaseT. I think HDBaseT had tremendous progress in the last couple of years, introducing brand new technology that is very exciting for us. I'll go a little bit through our basic technology, the way we use Cat5 in general and all the pitfalls, and also talk about HDBaseT a little bit. And I would love to answer any questions you may have. So before we go there, I'd like just in order to explain a little bit how the Cat5 connectivity came about, go through a short slide basically showing what is HDMI. You know what's HDMI, right? It's just a background slide. HDMI has basically many wires inside the connector. Major bandwidth consumption is taken by so-called TMDS, that's video and audio bus, that sends video from transmitter to receiver. There's also I2C bus that allows interactive access of keys, encryption keys, as well as edit information from receiver to transmitter. And there is some supporting information and supporting things that exist in the bus as well, the hot plug detect line, the CEC for control that's used between receiver and transmitter, some power, audio return, Ethernet, all this in HDMI connector. But one of the basic technological problem and connectivity problem today is TMDS. TMDS because TMDS is extremely high speed bus that transmits a lot of data, and that's the major problem of making long connections. As you know, if you use short HDMI cables, those connections don't work. I won't go through the history of HDMI, and I think it's redundant for this talk. I'll basically concentrate on Cat5 and what happens. Now, inside HDMI cable itself, was the first 12 pins I basically devoted towards transmitting of TMDS. And TMDS traveling in HDMI connector actually through a shielded twisted pair. There are 4 shielded twisted pairs inside HDMI cable. Each has an individual shield also available. So 4 individually shielded twisted pairs with the overall shield over basic HDMI cable. So that's important information to remember. And the other lines are basically presented as single connectivity lines. CEC line, line that used for Ethernet and audio return. The 2 lines they use for so-called I2C for use HDCP and edit exchange. Ground for all the pins, 5-volt power, and hot plug line. So this is all auxiliary lines used for a variety of services. But the basic technological challenge for HDMI cable is this. Now, inside the STP cable, or inside UTP cable, inside twisted pair, what happens? When signal originates in the beginning of the line, it's basic collections of 1s and 0s, and this is sort of time overlay diagram from the scope that summarized all the transitions from line and 0s and 1 inside that twisted pair. As you see, the 1 and 0 in the beginning of the line is well represented. You can easily distinguish between 1 and 0. So if you have a threshold line and you sense where 1 and 0 is, this, so we call data eye, is sufficiently open, and you can easily detect which one is 1 and which one is 0. Right? So you have a wide open data eye. Now, what happens when the data travels over the cable, HDMI cable or Cat5 cable, this fronts of these pulses gets less and less defined. It happens basically because of the bandwidth of the cable. The cable is not such a good bandwidth. It rolls off high frequencies and introduces nonlinear effects. So it creates jitter. So the fronts of this line gets thicker. The 1s and 0s now, sometimes high frequency pulses get attenuated. So 1s and 0s gets less and less distinguished, and the eye get progressively closed. Now, so if you now draw a threshold line in this area, now in the end, let's say a 100 feet run, you will say we still can detect 1s and 0s. But at some point, when the length of the cable, HDMI cable, which is twisted pair for TMDS, for all the purposes here, gets longer, this eye progressively gets closed. And at some point, it closes completely. And when it closes, we call it a catastrophic failure. so-called, and then it presents a cliff effect. So if you have a too long of HDMI cable or Cat5 cable, the data disappears, so you fall over the cliff, and there's no more data. So that's the problem in the either HDMI cable or any Cat5 cable that sends this data over Cat5 cable. There is a cliff effect. Now, of course, the cliff effect can be mitigated by a variety of methods. One method is increased bandwidth of the cable. The cable has more bandwidth, so the fronts become thinner, so the eye increases. The other way is reduce resolution. If you reduce resolution of the data, then the clock of the data gets, let's say, 1080p versus 1080i. The 1080i cycle clock is twice as big, so the data eye is twice as big, so it lasts almost twice as long. So essentially, you can detect data farther using lower resolution, or you can increase bandwidth of the cable, or you can do both. And also, in one of the ways we're actually using this technology today is using so-called equalizers. The equalizers are what they do. They equalize the loss of the cable in reverse order and effectively stretching the size of the eye opening at the receiving end. So there's a variety of ways to approach this way and in order to receive the data. But as you know, in digital transmission, the cliff effect is an interesting phenomenon, but you have to be careful with this, because if you use analog transmission technology and the cable becomes longer and longer, you gradually decrease of picture quality. In digital world, you still detect 1 and 0. The data on the cable is still very bad, but 1 and 0, the way they represent on your screen will look exactly the same. So you won't see any quality degradation until the point then your data eye is closed, and then the data drops and you see nothing. So that's one of the very practical considerations for anybody using twisted pair or HDMI cables, is to stay away from the cliff. Don't fall over. And that's very important, because if you fall over, then there's no data. Now, if you go farther into Cat5/6 connectivity, of course, there is no more than one twisted pair. There are 3 twisted pairs there that carry data and 1 that carries clock. So if the alignment of these twisted pairs is not perfect and they are jittery in the begin with, then you have a data opening opportunity to actually read the data is different between different pairs. And you may actually lose data just because the delay is different on each twisted pair, and arrival time for each data is different at the receiving end, even though the eye. So all these things affects data reception: the bandwidth of the cable, the alignment of the between different twisted pairs, the resolution of the signal, how fast the clock is moving. All of this could actually terminate your connectivity. So I made this simple chart that basically explains what happens with length. So this is sort of one-dimensional chart. Basically shows the degradation of the data performance over Cat5/6 cable versus distance. And using so-called EQ, equalization, how this degradation could be actually compensated on the other end. So in order for us, if we don't have any EQ circuit, which is a passive HDMI cable, again, twisted pair that has TMDS signal on it. If you don't use any EQ, then the effective length of the connectivity, now there's difference between manufacturer to manufacturer, but you can roughly say this will be about 30 feet for 1080p 60 and 60 feet for 1080i 60, after which probably is going to be cliff effect in majority of the cases. Now if you use EQ and you actually stretch the data eye in the end of the cable and open data eye again, you actually can prolong the death sentence to considerably more distance. You can go up to 150 feet for 1080p 60, 270 feet for 1080i 60. That's conventional technology. That's not HDBaseT. So this is kind of what we up to now keep working with and making our systems work. Now, there's a few different EQ systems. Actually, I'd like to say a few words that to extend HDMI cable capability, some people use EQ boosters on the end of HDMI cable that effectively do the same thing. They reopen the eye, they equalize the cable, and they can make the length of the data probably going up to 125 feet. There's some cables, but in recent days, no more. There's very little people who offer this kind of a length, and most of this from 70 feet and up is taken on with balance extenders that use straight Cat5 cable, Cat6 cable to make this connection. Huh?
Why is that?
Cost. The cables that has 125 feet is very expensive to make, and additional thing that ease of installation. It's much more difficult to pull 125 HDMI cable than Cat5 or Cat6 cable that you can terminate yourself to a length that you need. So that the extenders balance, they use Cat5, Cat6 wiring, completely cut this product out of the market. On a troubleshooting side, the basic troubleshooting, I would say there's a few practical suggestions. One of them is watch for pepper and salt. Pepper and salt is that when you're standing next to the cliff, some data points will be lost. So, and those database points will result in the image as rough alteration of the brightness or color of specific pixels. And you can see it if you bring yourself close to the screen and you put some very gray image without any details, any motion, just a gray image. And if you watch close to the screen, you'll see pepper and salt on if you're close to the edge. And then you have to take some measures, because that pepper and salt, meaning that you're close to the cliff, and with some changes in environment and humidity and mechanical vibration, the connection could get worse, and you can quickly fall over. So in that case, you have to do some measures. Maybe you have to lower resolution to go to 1080i and jump back from the cliff. Maybe you need to shorten the length of the cable somehow, or maybe you have to use a better cable that has more bandwidth and less shielded cable. It gives you a little bit better performance. So that's kind of a couple of practical. Also bending, sharp bending of HDMI cable or Cat5 cable also has a problem, because it introduces a nonlinear change in the twisted pair and may affect bandwidth of the cable. Now, one of the so far used some technologies used for transmitting HDMI over Cat5 is so-called dual Cat5/6 technology. That technology takes advantage of the fact that there is a TMDS data within HDMI cable and non-TMDS data. So TMDS data is separated and sent separately over one of the Cat5/6 cable as TMDS data. It's not getting changed much. It's only a little bit conditioned for the cable itself. And on the other end of the cable, post EQ is used, powerful EQ circuit that actually reopens the eye for you to get the data back registered as more or less clean data for HDMI out. So this is what one portion of the data. Another portion of the data, which is very slow data, which HDCP either to high plug, is sent over a second line through basically data buffers, because the speed of that data is so slow that the jitter effect is yet to take effect in the distances of 150 feet or 200 feet. The jitter effects are very small on such a slow data, and it can be easily registered in this distance. So the handling of it is simpler. You don't need a very powerful EQ to recover that data. But that is where the holy grail is in order to recover it. So this is sort of low-cost implementation. It's widely used today. Some people easily trading complexity versus putting another Cat5 cable. And at distances 100 feet, 150 feet, and with 1080i 200, 250 feet, this works well and used throughout the industry. This is an example of this balun that we sell. We call it Cat HD. It's a very simple product. Has HDMI input, HDMI output. Has two Cat5 jacks for two Cat5 cables. Basically supports all the resolutions and supports, of course, audio that's embedded within the signal. And you know, it's a low-cost, easy way to send data over Cat5. In basic troubleshooting of this device, there's basically not much difference that what we just talked about HDMI cables. The reason is that it's the same type of data, the same type of sensing, looking for pepper and salt. I recommend. You don't have to reverse TX or X, don't reverse data lines and video lines. Basically straightforward techniques, no sharp bending, and using shielded Cat6 always helps because it avoids interference from outside and actually makes the ground common on both ends, which unifies the ground instead of ground interference and ground loops that may present in long distances. So how we send all this data on single wire? Now we developed the method ourselves that is still using a TMDS method. What we do is, since TMDS data is essentially high frequency data, we place it, it occupies in a frequency space specific bandwidth in this area, which is very high bandwidth. And on the same lines, we have available, available spells in the low frequency that we adding a HDCP and EDIT IR and 232 data in a low frequency area. So we sort of create in a way a frequency plan. Similar to what you have, let's say, in cable TV system when you can dial different channels, channel 700, channel 50, channel 20. In this case, the high frequency channel is TMDS and the low frequency channels are digital audio, HDCP, EDIT, IR, and 232. It happens to be that these signals, EDIT, IR, and 232, can be combined together to form one channel. And this signal, HDCP or digital audio, could also occupy a little bit higher frequency channel, but both of them can live together with TMDS on a single line. So we made this kind of a system. We mix this all together. We separate TMDS through high-pass filter. We use HDCP or external digital audio through bandpass filter, and this low data, EDIT, 232, and IR all goes to low-pass filter. They all get mixed, sent pre-EQ'd, sent over single cat 5 or 6 cable, and then received and EQ'd on the other end, and then separated again through these filters, being then offered on HDMI cable to the external device. So in this case, we actually mix them all together, multiplex, we call it frequency multiplex, and then frequency demultiplex on the other end, and present. So this kind of a product still have the same length limitation because we didn't change much in the physical nature of the data. We only made it more convenient for the customer to, instead of using 2 Cat5s, they can use 1 Cat5/6 cable now. And the cost of this installation transferred back a little bit into electronics. So instead of using second cable, there's more hardware here in order to transmit and receive all this data. This is an example of this product. Actually, it's a little bit better picture that has a HDMI or DVI. You can send HDMI, DVI. You have audio that becomes active when you use DVI because no HDCP is used. And you have 232 bidirectional and IR bidirectional all present all the time, and single Cat RG45 for the Cat5/6 connection. So this is we call it BB, and that's product we use now for this kind of connections of distances 150 feet for 1080p or 300 feet for 1080i. Now this is a simple diagram how connection can be made. IR to 32, HDMI, all go through one cable. On the other end, you can use different 232, different IR for different control of different devices, and sort of simple representation of this technology. HDBaseT is very, very exciting for us because HDBaseT is a full departure of the TMDS method. It's a new technology. You probably heard a lot about this. I don't know how much was said here, but we're very excited, and we actually also made a product that we're selling called CAT HD 500, and that product is using HDBaseT Valence chips inside to transmit data, HDMI data, for much longer distances than EQ method. As a matter of fact, the distances can be achieved 300 feet for 1080p, and if you use a 1080i version of the firmware, you can send data up to 500 feet for resolutions 1080i, 1080p, 720p, 480p. So this is a very powerful method and actually present much more longer communication than EQ-based method. The technology using special modulation scheme called 16PAM that use special bit error resistant trade-offs that actually protect data inside the modulation. More sensitive data is more protected than less sensitive data in the way it's sent over that wire. This is a very basic block diagram of our product. What we did here is that this is the first time that in the transmitting of HDMI over Cat5 or 6, there's complete departure from TMDS. The data is decoded into digital data from HDMI TMDS and get reclocked, cleaned up, and get mixed in with many other types of data because the data capability on the HDBaseT is much greater than data capability on TMDS method. And because data capability is greater, there's much more data can be added into the mix. 232, IR, and also Ethernet, all are transmitted on this single Cat5. The data is packetized and then it passed through the special 16PAM modulator that uses both amplitude and time to modulate the data and to send it over and decode it on the other end. So in our case, what we did also, in addition to it, we also added EDIT control. This way we can actually not only rely on EDIT that comes from the receiver, we can essentially replace the EDIT from EDIT library that we developed, and it actually helps a lot in solving a lot of problems in current connectivity, because there are many mistakes that people make writing EDIT. EDIT sometimes needed different EDIT than TV. TV sends an EDIT for a specific demand, and you may have an installation that requires different EDIT. An example for that is, for example, you have a TV that has 2 speakers, and that TV will probably request from the source 2-channel stereo as audio. Now, when the source device sees that EDIT, it most likely will put 2-channel stereo on every audio output. So if you have a surround sound system connected to that source, you may have a problem of decoding, let's say, Dolby Digital or DTS HD, because the EDIT information demands that the source will send 2-channel stereo. So in order to change that phenomena, especially in custom marketplace that we really need surround sound and we cannot rely on that part of EDIT, we found out that having EDIT control makes a big difference. And we, for example, allow you to switch EDIT from, say, 1080p 2-channel stereo that television set wants to 1080p Dolby Digital, or 1080p DTS HD. And in this case, the HDMI will include audio packets that will be actually will transmit high definition, will transmit multi-channel audio packets, and it will be available for your display on your surround sound receiver. And of course, the television set will show no audio, but that is probably what actually you want in that installation. So having EDIT control puts you back in control on HDMI installation. This EDIT is a very convenient thing for commodity, for low end, for consumer who buys, let's say, Blu-ray player and TV set from Best Buy and hooks it up by himself. He doesn't think what's going on. The Blu-ray player tells TV set what he wants, and they all the other way around. And the Blu-ray sends the data, and everything works fine without any adjustments. But for custom marketplace, when you have a very complex installation with multiple speakers, multiple displays, matrix switchers, a lot of interconnect, this kind of an EDIT that commends and makes your system be slave to specific display EDIT makes actually installation very difficult. So having EDIT control is very important.
How does it look, though? I mean, is it like ASCII control? Is it like a numeric thing?
Well, the way it looks is EDIT is a file. It's a file that is recorded in a small chip that is mounted next to HDMI connector in any TV set. The EDIT, by definition, is powered by the HDMI connector power. So even if you pull out TV set and you connect your cable TV box to TV set without TV set plugged into the wall, the cable set will already read that EDIT information using that power. So it's a very tiny file, 64 bits or 128 bits, that has information about TV set resolution, audio formats, aspect ratio, maker, and many, many other components. That's what it does. Now, what happens here is very simple. We read that file, and we offer you a choice. We can take this file and make it available again to the HDMI source, or we can, instead of that file, we have a library of 12 other files that sits in our memory right here for you. So we're fooling that source.
Pick a new file.
We tell you pick a new file. We give you a manual, and it's listed there. You have file 1 is 1080i stereo, then 1080i full digital, then 1080p stereo, 1080p full digital, then 3D stereo, 3D full digital. We have all kind of variations that you can possibly use in your installation. You pick the file you want. And since this control is actually implemented as a rotary switch, even without reading manual, you can go through the position and say, oh, this works. And actually, right. You have a rotary switch and a ballon, and you can actually pick up the file one. So this is a very simple process, doesn't take much memory, but the effect on the filtering the setting system to what you need is extremely important and makes troubleshooting and whole reliability of the system much, much greater. In addition, what we learned through the EDIT process, as I mentioned to you before with a slide where I show HDMI structure and HDMI cable, I distinguished between two sections. One section is that silicon that's made by, let's say, people who make HDMI transmitter and receiver. That was in purple on top. And on bottom was in green what's made by a receiver and source manufacturer. And that's EDIT memory and EDIT reading going through that bus. So what's interesting about this is that if, for example, a Panasonic maker makes a new TV set and he loads it with EDIT memory, ideally you would like him to test that TV set against every source possible. But it's physically impossible because there are hundreds of brands and they have probably hundreds of SKUs each. And it's physically impossible for him to go through all the testing in the world to make sure that it works with every possible brand. So there are mistakes. There are writing mistakes, there are reading mistakes. So it's far more prevalent, the EDIT mistakes are far more prevalent than HDCP mistakes. HDCP is buried inside the silicon, and it's usually 2 or 3 or 4 semiconductor makers who make the transmitter receivers. And they do test with each other. They do make sure that HDCP works. So the testing volume of semiconductor manufacturer versus the product manufacturer is completely different. And that's why the HDCP errors is less frequent. The EDIT errors is much more frequent. So that's the problem. And having EDIT control is extremely helpful in HDMI connectivity. So we have not only this balance, but every product we make, the switcher, distribution amp, matrix switcher, extenders, they all have EDIT control for that reason, because we know it really helps throughout installations. Now this is my simple sort of understanding how PAM modulation, HDBaseT, provides you more of the data capability. Now looking at everything before, as you know, if I take TMDS, which is like, say, binary 1 or 0 representation of the data, and let's say I want to send more data over TMDS, what do? The only thing I can do really is to make clock faster, because I will send those 1s and 0s faster and faster. When I send 1s and 0s faster and faster, my jitter effect's creeping in, right? The faster I send, the eye gets close, so I can send it on a shorter distance. Now in PAM there is a significant improvement because PAM allows you to send data in amplitude direction as well. So you can send, this is PAM4, a simple method, just 2 data samples, plus 1 volt is 0, plus 3 volt is 1, and so on. But in PAM16 you can send, on this direction, you can send more data. If you need more data, you can send it vertically, changing amplitude for each data sample that you want to send. as well as you have amplitude direction and frequency direction to mount more data. So essentially, you can trade off the clock speed versus amplitude to send more data. And if you lower the clock speed, your jitter effects get into effect later on. So you can send it on a longer distance. And since you have a vertical dimension for amplitude dimension for the sending data over amplitude, you have more capacity, not only ones and zeros, you can send more data vertically, more data representation vertically in amplitude than TMDS data. So the HDBaseT is a very innovative approach. It's tremendously powerful and actually makes correct trade-off for our business. It does many good things. It allows you to send more data on a longer distance and allows to use the twisted pair connectivity much more effectively than TMDS approach. I'm very very excited about this, because I think the HDBaseT basically will change around our complete marketplace as far as connectivity through Cat5, as far as creating metric switchers who has this kind of inputs and outputs. And I think it will be de facto connectivity for many commercial and residential installations. The HDMI cable will probably still remain for short connectivity, but for really industrial, commercial, high residential, and complex wiring system, that there's really no competition to HDBaseT, because it's a very advanced, very high quality system. This is the product that we make, HDBaseT Balun. As you see here, we have HDMI input. We also have HDMI throughput, which is input and output on the same transmitting device, which is actually very useful, because what happens here is when you have a connection of your monitor 300 feet or more away, you may want to have a local copy of your HDMI input for either local monitoring or, say, local AV receiver that you want to play back the multi-channel audio. And so we have HDMI input, HDMI throughput. We have the EDIT control. You see this rotary switch for digital. We have an Ethernet connection to provide the Ethernet connectivity throughout the system. This is the output of the HDBaseT Cat5/6 output that connects from transmitter to receiver. We have also full IR TX receiving and transmitting line that constantly are up and running. So they don't share one line. It's two lines that each available in both directions. There is RS-32 bidirectional. So it's a very exciting, very powerful feature-filled product that have many different features that accumulates a lot of experience that we learn throughout our business, and implements the latest HDBaseT modulation and handling of Cat5, Cat6 data. So it's a very powerful thing. As I mentioned before, it makes a long distance and very high capacity data transmission possible. So what about basic cable recommendations? When it goes back to using Cat5/6 cables, for either technology you use, it's basically the problem, the trade-offs is very similar. The cable bandwidth plays most important role. The higher is the bandwidth, of course, the less is jitter on the receiving end, so there's much more possibility to have eye open, alignment correct, and your data recovery on the other end. Shielded twisted pair is a very good idea. I recommend it highly, because it can prevent RF interference from outside of the cable, and actually, especially on the long run. There's another good advantage of using shielded, is when you use shielded twisted pair, you actually connect ground of transmitter and receiver together through the shield. Because on the long connections, like 300-400 feet, there's very good chance there's different power loops, different grounds, maybe not connected to the same ground. The ground may be floating, and that floating ground creates sometimes problem in detecting data. So the having STP connecting between transmitter and receiver actually makes the ground unified and make the system much more robust. Now, we also recommend, and we're making now this cable, and it has extremely high performance. It shows on our booth if you want to see it. We individually shield each twisted pair within the twisted pair cable. Individual shield has an additional advantage. It actually prevents each pair from interference from the neighborhood pairs, not from outside the cable, but from inside the cable. So that makes the cable transmission even more robust. We also, when we manufacture our Cat6 STP cable, we make sure that the twisted pair turn speed or turn rate is very, very close on each twisted pair to make alignment of the twisted pairs close to each other, and that way it prevents better capture. So all of this.
You're making your own cable.
Huh?
You're making your own
Yes, we are.
cable.
Yes, we started this business without making our own cable. When we went to Cat5, Cat6 business extenders, we thought naively that the cables are basically similar. We had a couple of cables in the lab. They worked well with our products, and we started selling products. A few weeks later, when people started using it on all kind of brands, we had tremendous amount of calls from the field. It doesn't work here. Why? What cable do you use? Finally, we found out that cables are tremendously different. There's a big variety of cables out there that perform completely different from each other. There's no guarantee. There's a big change in band. There's a big variety of bandwidth. There's a big variety of how they are aligned. There's a big variety how they mate and the quality of the cable. So at some point we went to the second. We started to recommend a shielded STP that is a good way of sort of preventing some mistakes. And finally, we decided that actually to guarantee the absolute top tip performance, we're going to make cables that we made ourselves. We know how to make, how it works. We tested with all our products. And that way, we actually feel most comfortable. This cable, when we make big jobs and people buy a large matrix switcher for us, or balance. Balance we recommend, but for large matrix switcher, we're just telling them, look, we're not going to sell you a matrix switcher if you don't use this cable. We don't make much money on this cable, but what we do, we'll lower amount of tech support that's coming back in. It just doesn't exist. Every time people use this cable, we don't hear from them. It works extremely well. So that is a sort of a practical thing that we do. Now the Cat5, since Cat5/6 extenders now become a basically well-established part of cabling. Even sometimes people use even 30 feet distances. They use Cat5/6. Still easier for them to snake the Cat5/6 there than to snake HDMI cable. It becomes such a default, de facto use with HDBaseT will definitely increase, that we already migrated a long time ago into actually integrating together a balance and matrix switcher. So this is an example of our matrix switcher that we call HDMI 8x8 that integrates together Cat5 connectivity and HDMI switching. So what we do here is that each input, it's a 16-base slot, each input has both HDMI and Cat5, Cat6 input, and it will allow you to, if you have 8 input devices and 8 displays, you can allow you to integrate variety of configurations on the input devices. You may have input devices that are far away, not at the point where matrix is mounted. Let's say it's a laptop computer, desktop computer far away. In that case, the user will have a transmitting balun that will convert HDMI into Cat5, connect it to the input card. Or if you have local devices like cable and satellite boxes that remotely controlled, this can be mounted together and connected through HDMI cable. So this kind of installation is an example of the fact that the whole system can be integrated together through one matrix switcher on variety of distances for variety of applications. And this is actually demanded by the user to have. Now, you cannot actually have matrix switchers today without you cannot be a serious matrix switcher maker if you don't have integrated Cat5, Cat6 outputs, at least outputs. On the input side, it's an open issue because not many inputs are needed to be long ranged. But on the output side, it's definitely the case. You must have an output, at least output Cat5 drives in order to be serious in this business. So that is an example of total integration. We're now using our own frequency multiplex technology, and we're migrating since we already made the balance, HDBaseT balance, we're migrating into converting that switcher to HDBaseT input and output switcher. So you can directly plug into the switcher. And if there are monitors on the market, and I also see some HDBaseT made some announcement of some partnerships with monitor makers that may integrate HDBaseT as part of their direct input, then that means in this case you can use the switcher directly, plugging a Cat5 cable between that switcher and the monitor without any balun in between. So that makes the system even more streamlined, more user-friendly. So if the marketplace goes that direction, then everybody who benefits to using HDBaseT will actually benefit to have a completely integrated approach, much more seamless, much more straightforward.
Are you saying you're going to make all your matrix switches
yes.
HD?
All matrices will be HDBaseT. Yes. Right now we make 4x4, 8x8. They're migrating to HDBaseT. And next year we'll introduce 16x16, 32x32, up to 256x256. All of them will be completely HDBaseT. And the reason for that is that when you have 64x64 matrix switcher mounted in casino or big commercial establishment, there's very little 20-feet connections there, because that room is definitely 200 feet from anything else from begin with. So it's always demands very long distances. It demands extremely hardened and very hardened and very reliable connection, and that's what HDBaseT offers. It's a no-brainer. If we would have HDBaseT before, we'll have these switchers also made in the first place, but we migrate.
8x8, but the smaller one will be.
Yes, we have HDMS 4x4 that is now using BB. It will be converted to HDBaseT. We have this HDMS 8x8 will be converted to HDBaseT. The only switcher, we have another switcher, we call it low-end residential switcher. They use two Cat5 technology. This is very low-cost thing for very low-cost installations. That will remain using 2 Cat5 but every single Cat5 product we make will convert to HDBaseT. So that's our goal, and that's our roadmap. I think it's my 4 o'clock is up. I really appreciate your attention and questions. Thank you very much.